Good afternoon to everyone, and welcome to the Aspect User Forum on Climate Prediction. It's a pleasure to moderate today's discussion and bring together such a diverse community of users and experts. My name is Jaro Misiek, and I'm with the Euro-Mediterranean Center on Climate Change. You might remember me from earlier edition of this forum. And yes, this is already a third annual event, but by no means less interesting than the previous two. So what we have prepared for you this time. First of all, this forum, which is hosted by the Horizon Europe project Aspect, is a key opportunity to explore how advances in climate prediction can better serve real-world decision-making and strengthen resilience across different sectors. Second, it consists of 3 sessions that are held between today and Thursday, always the same time, and each session will last for 90 minutes. So today we will be talking about the climate prediction in general. So you don't need to have the technical knowledge about climate predictions. You will learn what we are doing, how the climate prediction might be useful. This is what we call community of interest. So anyone is very welcome to join us and follow the discussion and learn a lot about predictions. Tomorrow's session will be a little bit more technical, and we call it the community of practice. So we will be talking about the technical choices behind running the climate predictions, as well as the technical application, real-world application, showcased on an example, on several examples. And we will also be talking about the user or community benefits from those. And lastly, on Thursday, same time, we will be hosting a marketplace. That means a matchmaking event. So there will be a representative of the climate service providers and user debating and pitching the application, they request, they demand, and the solutions. So it's altogether, it's quite a rich event offering something for everyone. And we hope that we will see you also tomorrow and day after. So coming back to today's program, we will be talking about Aspect Project, which is hosting this forum, and it's also developing seamless climate predictions. And we have first the keynote speaker, Bina Balan Saroyani, who is a member of Predictability of Weather and Climate Group at the University of Oxford. And within Aspect Project, she co-develops methodologies to connect scientists with external users for enhanced climate prediction applications. And our second keynote speaker is Freya Gary, who is a part of the climate resilience team at the Met Office in UK. And within the project, she co-leads the work stream that is focused on developing prototype climate services with key users. We call them super users. So without any further ado, I would invite Freya and Bina to take the floor and talk us through the project and what the project is aiming at. Thank you very much.
Thank you. I will just share the screen. Hopefully that's worked. So we're going to share with you an accessible overview of what our scientists in Aspect have been doing during 2023 and 24 and where we're going for the rest of the project. So as we said, we're not going to get into too many of the technical details today, but hopefully we'll discuss a bit more technical detail tomorrow. So we hope this will be accessible for people from many different organisations, or if you're just interested in using climate information to understand present and future climate risk. So the Aspect project is a very ambitious project with a huge breadth of activity. So this hopefully will be a good introduction or a reminder of what we're doing if you've joined us before. So, broadly, the key areas we're going to talk about are the model experiments that are being created, and what our expert scientists in seasonal to decadal prediction are learning from the latest model experiments. And then we'll talk about how we're drawing that learning through that we can then use to create new climate information that we can develop tailored climate services that are both useful and usable for decision making across multiple sectors of society. So this diagram shows the range of timescales that as humans, I think we mostly think about from weather through to climate. And it highlights the range from greater than a few months to 20 to 30 years in future that is the focus of the Aspect project. So really keen on helping people get the right information to help people make decisions on relatively near-term adaptation to climate change, as well as 20 to 30 years time. Um, and we often talk about weather forecasts and climate predictions, and therefore, in seasonal to decadal timescales, we often hear both of the words seasonal and forecast and prediction being used. So here we're just going to try and use the word prediction, but if you hear us refer to the word forecasts, here we mean the same thing. So this plot shows different scenarios for future climate change, which represent different possible futures that humanity could follow, depending on how fast societies transition away from using fossil fuels and towards net zero. When we zoom in to looking at the next 20 to 30 years, we can see in all of these scenarios that we still expect to see a rise in global warming, and we know that some places are and will warm faster than others. We're already experiencing climate impacts around the world, often affecting vulnerable people the most. So there's a need to adapt to climate change and the increase in extreme weather will continue to see. So, in Aspect, we're aiming to improve on these long term scenarios by using more information about shorter natural variations that happen to the climate and information about what our climate looks like right now. Is it warmer or cooler than we might expect? This extra information is part of the seasonal and decadal predictions that we make. So when we look at these predictions in your location, where possible, we're trying to use this information to give you a better idea of the near future and the risk you may be likely to face from climate change and impacts to help make better decisions. Before the Aspect project started, there are already different experiments being produced by many expert scientists involved in Aspect and other groups around the world. And in the past, these seasonal experiments gave predictions up to about 6 or 7 months ahead and decadal up to 10 years ahead. So, as we've mentioned, the climate predictions give this better near term information compared to climate projections. Whereas projections are really helpful for understanding the long term climate change, but the setup of the experiments is slightly different. There's lots of these natural variations in the climate lasting from a year to decades that happen on top of the ongoing warming trends. And they don't tend to happen in the same time in climate projections as in the real world. So, seasonal and decadal predictions aim to bring these variations in sync, giving more useful information for near term decision making. So, in the Met Office and the World Meteorological Organization predicted in 2022, for example, that there'd be a 50-50 chance that we'd get one of the next 5 years being over 1.5 degrees warmer than before humans started burning large quantities of coal, oil, and gas in the pre industrial period. So, this happened in 2024. This is an example headline prediction. but the same experiments can be used to try and make predictions in more local areas as well. We can see here the annual average temperature prediction for 2025 made recently by the Met Office, with the range of the global average temperature predicted for 2025 shown by the vertical green line. So shows that we expect the 2025 global average temperature to still be between 1.25 and 1.5 degrees higher than the pre-industrial, but slightly cooler than 2024. However, this will probably mean very hot summers in many places. When we think about the decisions that might be made from this, a hot summer could be associated with poor crop yields in Europe, as hot summers also tend to be dry, and so extra irrigation may be required for farmers to help keep crops healthy. So, the first part of the Aspect project is to make some new experiments to help improve predictions over the coming years. And this slide outlines some of them. An important way of being able to test how good future predictions are is to use the same experimental setup in the past, where we know how the climate behaved. And then as science moves forward, we're also improving climate modeling. So new improved versions of models are being used in aspects compared to previous experiments. And for example, models are made up of lots of little boxes representing an area of the land, ocean, or atmosphere, and these all talk to each other. By making these boxes a bit smaller, we improve how well we can represent some processes in the model. Finally, it's really important for predictions that we repeat each model experiment many times to create an ensemble. On the next slide, I'll explain why this helps us make better predictions. The reason ensembles are so important is because it's very unlikely that one simulation of the future climate will give a very accurate prediction because there's lots of natural variations in how the climate behaves. So, one prediction, so the red line on this diagram, will end up in one place, which is across. So, it might give an answer that looks really precise. However, we know that if we run the model many times, we get various different possible outcomes, which gives a more accurate answer. And by averaging the model simulations together, we can get a better prediction than we can from one simulation. It's even better if we can make an ensemble of different models from different groups of scientists, which is what we can do within the Aspect Consortium. We're also creating some experiments that are longer than the normal seasonal experiments. So instead of predicting the next 6 months, we have experiments to help us predict the next 2 years. And these experiments are currently being analysed. For the decadal experiments, we've also created some longer 20-year experiments as well as 10-year experiments. This enables scientists to try and make better predictions further into the future. And some groups are even performing a prediction experiments to 30 years ahead to help us understand how the climate of the next 30 years is likely to be different from the climate of the last 30 years. So this slide just shows which of our Aspect Consortium partners are producing these new experiments, with each centre using a different model. A lot of some supercomputing power goes into the creation of all these model experiments. In fact, we've estimated that the Aspect project might produce up to 2 petabytes of data from all these model experiments, which is about 2 million film downloads. So I'll now pass over to Bina to continue the presentation.
Hello everyone, thank you Freya. I'm going to continue giving you an overview of the next two exciting areas of Aspect. Firstly, the learning in Aspect, what our expert scientists in seasonal to decadal prediction are beginning to understand from the latest Aspect model experiments that Freya has just explained to you. Secondly, how we are converting that learning into creating new climate information and products to help co-develop tailored climate services that are both useful and usable for your decision making. Before talking about the new learning in aspect, to those of you who are new to prediction, I would like to introduce two common terms used in prediction. What are predictability and skill? Then I will share some expert knowledge on our current understanding of where predictability and skill are coming from and how good our estimation of extreme weather events is. Next slide, please. What do we mean by predictability? Predictability is the ability or extent to which future climate may be predicted based on the knowledge of the current and past climate. It tells us how well and in advance we can predict the climate over a given region. Prediction or forecast skill is any statistical measure of the accuracy or quality of the future climate information. It is based on how well the previous climate could have been predicted. In scientific language, the predictions of previous climate is called hindcast or reforecast. Next slide, please. Freya has earlier mentioned the relevance of climate variations or climate wiggles in predicting future climate. Scientists call it climate variability. These are natural climate variations that happen to the Earth's climate even before humans have started burning fossil fuels. Some of you may have heard of such natural climate variations such as El Nino Southern Oscillation or ENSO, North Atlantic Oscillation or NAO. The most important or globally relevant climate variation for global and regional climate prediction is ENSO, El Nino and La Nina events, which happen every year. That is what constitutes ENSO. El Nino is the warming of tropical Pacific Ocean. And when it is warmer than usual, the red shading, as we see in the bottom plot, we call it an El Nino event, and it lasts for about 9 to 12 months. And La Nina happens when it is cooler than usual, the blue shading in the bottom plot. So as I mentioned, the bottom plot shows local variations in sea surface temperature over eastern tropical Pacific over last many decades. Now let's have a look at the top plot. The black line, which you see, is the upward trending. Black line is the global warming trend. And the red wiggles over the upward warming trend is the natural variations. We call it. So we can see that the highest red wiggle, if you look, which corresponds to 1997-98, that coincides with the highest positive number or the warmest year in both the plots, in both the bottom and the top plots. We know that 97-98 was one of the strongest El Nino events we witnessed. The hottest years on record, like 2023, that Freya showed us earlier, had strong El Nino events too. And the prediction for 2024 depended on how well the current El Nino event lasted through the year. By current El Nino, I meant the one which happened in 2023. It ended by next year, June. It demonstrates that the global relevance of ENSO and the importance of realistic representation of natural variations at the start of the prediction experiments are crucial. This is a key element in aspect predictions. Both ENSO and NAO variations are important for predicting European climate. Next slide, please. We learned what predictability and prediction skill are and climate variations as a source of global and regional climate prediction skill. The next knowledge I want to share is that we can make better predictions of temperature than rainfall. This is because rainfall prediction is far more complex than temperature, as rainfall is affected both by a local warmer ocean and remote variations like ENSO happening in the tropical Pacific. The plot shows the European centers contribution to Copernicus Climate Change Service, seasonal forecast for the last summer, sea surface temperature forecast are shown, which was produced in March. That means the forecast started in March. Warmer areas of the ocean are shown in orange to red colors. The 2023 El Nino fully developed in summer is evident in the seasonal forecast produced 3 months in advance. We can see the warmer tropical Eastern Pacific. Recall that 2023 was one of the hottest years in record. We can see how widespread the warming is around the global oceans. What is happening in the tropical ocean influences what is happening in the world in the coming season, especially in regions impacted by the ENSO cycle. Seasonal prediction skill tends to be better in the tropics than further north or south, such as Europe. Aspect scientists are exploring whether ENSO can be tracked up to 1 to 2 years in advance using the new aspect multi-annual experiments. The takeaway message here is that although El Nino is a locally occurring Pacific Ocean event, as Freya told us, both ocean and atmosphere talk to each other and the information gets carried long distance through the atmosphere, making the predictions elsewhere in the globe better. Next slide, please. This is similar to the summer prediction plot we saw earlier. That was for summer 2023. This plot shows a comparison between summer 2023 and summer 2024. These forecasts were both started in March to the corresponding year. So we can see that if we look at the tropical Pacific, the difference is red shading and blue shading. So the blue shading indicates the tropical Pacific Ocean surface has cooler waters in summer 2024. That is when the ENSO, which started in mid-2023, ended. So we can see that the forecast model, here the ECMWF1, predicted the end of ENSO started in June 2023 and its transition to near neutral conditions. We have seen its effect, which was reflected in the annual average temperature prediction for 2024, as Freya showed us earlier. What happens in the tropical oceans affects what happens around the world in the coming season. On timescales longer than seasonal, say for decadal to multi-decadal prediction, the predictability primarily arises from the current observed ocean climate. Knowing what the North Atlantic Ocean does helps scientists to predict European weather and climate in both winter and summer. The plot shows observed warmer sea surface temperature over the northeastern Atlantic coast in June 2023. We can see that it's up to 3 degrees Celsius warmer than the last 3 decades, which helps predict what European climate is likely to be. This is an upcoming research area and aspect that needs to be studied using prediction models from many European prediction centers. So these are 2 examples of windows of opportunity for seasonal prediction. Aspect scientists find that predictions started when a El Nino or La Nina is happening have higher prediction skill in air temperature and rainfall multiple years ahead compared to predictions started with neutral ENSO conditions. The plots here show that rainfall changes for an extreme event during summer 2022 predicted by the Metaphys decadal prediction model is comparable to rainfall observations. Aspect scientists find that extreme rainfall, which caused the Pakistan floods of summer 2022, could have been predicted because it was preceded by an unusual summer La Nina. And aspect scientists are also looking whether what we see here is also represented or reproduced in other forecast models. Next slide, please. For the European winter climate, aspect scientists have previously found that the prediction skill in decadal timescales of rainfall is linked to decadal variations in North Atlantic Ocean temperatures and the North Atlantic Oscillation. Compared to winter, European summer climate has relatively low prediction skill. This is another example where aspect scientists have explored potential mechanisms which give rise to prediction skill up to 2 to 3 years ahead for extremely warm European summer. The schematic diagram shows how heat built up in the subtropical North Atlantic Ocean, indicated by the pink plus signs, over the 3 years influence the atmosphere above and the European summer weather. User needs are wide-ranging, depending on the time and spatial scale the information is needed for. For example, a particular user may need climate risk information, whether rainfall will exceed over a user-driven threshold in the coming season or decade, over a very small location of a single asset, say a farm, a river basin, or a village. Sometimes the decadal prediction skill alone is not high enough to provide such localized rainfall predictions. This is an example where new hybrid methodology was provided to combine information from decadal prediction models with that from statistical models. And it provided climate services to hydroelectric energy sector over 3 Mediterranean river basins. Next slide, please. The most catastrophic manifestation of climate change we know is the increase in frequency, intensity, and duration of extreme weather events, especially hot, dry, and wet extremes, which we know will happen more often in a warming world, threatening lives and livelihoods of millions of people every year. Scale of extreme weather events in the seasonal to decadal timescales are rarely studied in the past. On this diagram, we show the increase in frequency of different types of extreme events causing damage to society over the past 40 years. This is an area in which aspect will focus on, and the aspect scientists have been involved in a recent study which shows encouraging results on decadal prediction skill of temperature extremes. This recent study by aspect scientists estimates that Europe is likely to experience end-of-century-like extreme heat and drought events repeatedly, with events typical to the end of the century likely to be experienced within the next decade. Warm decades over Europe are twice as likely, depending on a warmer North Atlantic Ocean. With that, we hope you have got an overview of how aspects, new experiments, and new learning and understanding are beginning to evolve. The next exciting area of aspect is to create new climate information to co-produce tailored climate services for user needs ranging from different spatial and temporal scales. One of the techniques in creating new climate information in high spatial resolution is downscaling, which is an active area in aspect. Aspect scientists use advanced statistical and machine learning methods to convert coarse resolution information from climate models, for example, from a 60-kilometer square grid box, to provide useful information about hazard likelihood at the location of a specific asset like a vineyard of 4-kilometer square area. The next methodology to create new climate information is called temporal merging or temporal combining. This is to provide seamless climate information across different time ranges. For example, Frey explained that there are seasonal prediction models providing climate information in the seasonal range, and decadal prediction models providing climate information in the decadal range, and climate projections providing climate information in the time range greater than 10 years. In climate projections, natural climate variations are not represented realistically. As a result, although the long-term changes are predicted, short-term wiggles may not be in the right phase and results in erroneous predictions in the short timescales, which is the timescale that most often a user needs actionable information for adaptation decisions. A key innovation in aspect is to provide climate prediction information along timescales where there is a current gap in the forecast horizon. That is from 1 to 3 years, like multi-annual timescale we call it, and 10 to 30-year timescales. That is the multi-decadal timescale. In the temporal merging technique, we try to provide the existing climate information seamless along the timescales. This means you will get to see the seasonal and decadal timescale information or seasonal and multi-annual timescale information together in a single time series. It is a complicated task, and aspect scientists are developing new methodologies to co-produce adaptation-oriented seamless predictions of European climate together with the requirements of the key users of aspect. Another role for aspect is to promote the availability and accessibility of the existing seasonal to decadal information you can use in the development of climate services. I would like to share with you some information regarding where to look for existing information, as there are many sources of useful online resources on seasonal to decadal predictions from many European organizations. For example, German Weather Services or Deutsche Wetterdienst hosts a web page with monthly, seasonal, and decadal prediction information tailored separately for basic, intermediate, and expert user levels. For example, look out for the traffic light system, which is very interesting and very conveying. I would also like to point out the Shiny apps available on the Barcelona Supercomputing Center webpage for interested users to compute and visualize prediction information, including that of extremes in both seasonal and decadal ranges. The third point to highlight is the seasonal forecast skill visualization available alongside the graphical forecast products link on the Copernicus Climate Change or C3S climate change for seasonal C3S seasonal forecast webpage. Using a new exciting tool called Climate Pulse, you can feel the pulse of our climate at your fingertips now. Finally, new experiments and climate information produced in Aspect will be hosted by the European Centre for Medium Range Weather Forecast Data Service. I will now pass back to Freya to talk more about how the user-relevant climate services are being co-produced in Aspect to facilitate seamless decision-making. Thank you very much.
Thanks. So, as we talked about earlier, we know in reality any organisations making decisions about next quarter, next year, and when considering the future impact of climate change, maybe 5, 10 or 50 or more years ahead. And this is true across a range of sectors, from agriculture to humanitarian to health sector. When the decision making is in the near future, over the next year or two, when that doesn't account for the long term impacts from climate change, there's a risk that people may make decisions now that may make things more difficult for them in the future. They may adapt in a way that actually leaves them more vulnerable rather than more resilient. And so, for this reason, it's important that decision making is consistent across different lengths of time into the future. So, although we've talked about seamless model experiments and seamless data, we're also talking in our climate services about how to support seamless decision making around climate adaptation. And so we're working really closely with 5 key organisations from different sectors. So, as Yaro said, we're calling them super users, although we're also continuing to engage with a much broader range of users through activities such as these user forum events and other activities as well. You can see here on this overview diagram about our super users how the decisions being made by these different users span the different seasonal to decadal prediction to climate projection timescales that are the focus of aspects from season ahead to next 30 years ahead. The first super user from the agricultural sector, Cordon New, is interested in understanding how climate variability and change is impacting on spring frosts and water availability for their vineyard. So aspects can help support decision making to promote better crop growth. The second super user is the pension sector. We're actually engaging with a range of people to help develop this case study. The pension sector are concerned about climate risk, but largely do not use climate information in their decision making in a meaningful way. So, by creating examples of how climate risk can impact pension portfolios, aspects going to help demonstrate how climate services can usefully help decision making in the finance sector. Another super user is the governance sector, aspects working with the EU mission for adaptation, helping to support regions to understand climate risk, aiding strategic adaptation, climate service utilisation, and early warning system improvement. The case studies focusing initially on the Emilia-Romagna region of Italy, one of the most hazard-prone areas, through engagement with the Regional Agency for the Environment. We're also working on humanitarian sector interests, including responding to heat waves with British Red Cross and how we can use climate data to help with responding to malnutrition with Save the Children International. As I've said, we're also looking beyond these 5 super user case studies because many other organisations will find seasonal to decadal climate information and climate projections as well really useful for their decision making. And we want to provide examples of new prototype climate services that could also be used by other organisations and that can be adapted for the different needs and decision-making contexts that different organisations will have. This will help us to deliver more impact from the project overall. Through undertaking surveys, social scientists within the Aspect project are investigating scalability for a wide range of potential users of Aspect climate information. So please do keep engaging with our user forums, the rest of the activities this week, the discussions we're holding, as well as the other activities that you can hear about through our website newsletter and social media. As users of climate information, we really appreciate your input into the Aspect project. Thanks very much for listening to this overview of the Aspects project, and now I'll hand back to Yarrow to continue the session.
Thank you so much, Freya and Labina. That was really exhaustive and very nice. Nice presentation. I'm looking at the audience, and you are please feel free to post your question or comments in the Q&A, and we hope that we can answer some of your question. But I would start perhaps with something something easy. I would perhaps first my question would be to Bina, and this is a very simple question. I'm an environmental economist, and I'm trying to translate the insight from climate modeling for our users. So the really bottom-up question would be: can we predict something what we haven't seen in the past before? For example, right? Can we predict that certain tropical cyclones will emerge in areas where we haven't seen them before, or can we see certain phenomena they are extending the spatial range to the areas for which we don't have any instrumental record of their occurrence? Does the climate prediction system help us to identify those ways? And for Freya, this bottom-up, really easy question would be, if I think of Windy app, right, something which is quite understood and used by a large number of people, the Windy, right, you might know it, it shows certain meteorological and climate indicators. So what would be your judgment? How far are we with the climate predictions between now and the future when the user will access the climate predictions in an app like Windy? When do you think, how much time do we need to get the knowledge and understanding to this really on the ground level for everybody to access? Bina, would you like to start first?
Yes. Thanks, Yarrow, for the a very interesting question. As we highlighted throughout our talk, like one of the key aspect is trying to explore is through initialized predictions in those 2 forecast horizons, which is from 1 to 3 years and from 10 to 30-year timescales. So currently we don't have, before Aspect, we didn't have predictions in those forecast horizon. And these 2 new type of prediction experiments, Aspect scientists have found that for example, there is predictability for ENSO events in the multi-annual timescales. So that is one of the areas. And as we saw in our talk, the good prediction of ENSO means that we can get good predictability over regions where ENSO impacts. Regarding the question about tropical cyclone, a personal experience from my own research at the European Center for Medium Range Weather Forecast, we have seen that when you improve the in situ ocean observations in the initial conditions we prepare through data assimilation systems, that is the initial conditions from which the forecast starts. So if you can improve these initial conditions, the predictability increases and you get to reduce model errors in the forecast model, which improves tropical cyclone predictions. For example, over the Gulf of Mexico region, where forecast models do struggle to get predictions better. And another example, I am talking about the impact of ocean, because as we saw in these longer timescales, the predictability comes from slowly varying components of the climate system. So that's one of them is ocean. So here we also see that in the current seasonal forecasting system at ECMWF, if the in situ ocean observations, we have both in situ and satellite observations to constrain the initial conditions to make them realistic. So here, if you remove the in situ ocean observations, you see that the ENSO skill reduces by about in the range of 20 to 30%, if I remember that right. I have a publication if anybody is interested to share too.
Fantastic. Thank you. Thank you very much, Bina. And back to Freya. So, how far are we from using the climate prediction on the daily basis? What do you think?
That's a great question, actually. So actually, I think that it is possible that we could be using this data. It's actually something I was talking to Harris from ECMWF about from our consortium a few months ago. It's actually, I think it's a bit more of a technological and funding problem. This data has to be available on certain types of disks. And once it's there, actually, ECMWF are already proving that they can build technology like the Era 5 Explorer, which some of you may have seen recently, where you can, on an app interface, access climate data really quickly. And so that same principle is true for both predictions and projections if the data is able to be rapidly accessed, which is a technical issue that I don't know very much about myself. But loosely, that's the broad gist of it. And the important thing, though, is in providing prediction information that we give some indication of whether it's likely to be skillful in a particular area or not. And so Bina mentioned in the keynote about, for example, DWD's traffic light system. So there are ways that indication can be given in a user-friendly way, so we know if it's skillful. We can use that in combination maybe with climatology and climate projection information. But if it's like negative skillful, it might actually give you a misleading idea. So maybe you want to rely on your climatology and climate projection information only for that place. Yaro, are you still there? Yaro seems to have disappeared. But if there's any other questions, do we have a question?
Yeah, please put your questions or raise your hands till we get Yaro back. I can also ask some questions to the audience. In the meantime, how many of you currently use climate information for your day-to-day use? whether it is climate projection information or whether it is climate prediction information. If it is climate prediction, on what time scales and what spatial scales do you need the information for?
Is there anything you can tell us, Mina, as well about the predictions for the rest of 2025 in a bit more detail? What's the gossip from the
As far as it's gossip, yes. I think we are as we know in the predictions in the seasonal range keeps updated depending on how the ENSO conditions evolve. Right now, it's a near neutral situation in the tropical Pacific, but once we cross the spring predictability barrier towards the summer, we can get clearer picture, and that is when we would be sure of whether it's a near neutral condition or mild La Nina condition.
Can you explain a little bit more about what you mean by a spring predictability barrier for anyone who's not familiar with that?
This is the time period where you are not able to inherently predict, and so what we can't predict what is going to happen in December, for example. Whereas once we have gone through the springtime, the predictability is known to increase. Once we know what is happening in the summertime, then we are for sure what happens in winter is more reliable. That is the spring predictability barrier in a common man's term. Whereas for the Yarrow is back for the Europe has quite warming trend in the coming months, except for southwestern Europe. But this can vary again because it's more in the smaller time scale. Hi, Yarrow. Nice to see you back.
Thank you very much for covering up for this technical failure. We lost the internet connection at the institution, and our supporting team is going to join in a second. Thank you very much for your really insightful contribution to the debate, for your interesting talk. I think we need to move ahead. We have an interesting panel of experts on climate predictions. So let me welcoming our three distinguished panelists. The first one is Birgit Manning, who works at the Deutsche Wetterdienst, the German Met Office, and she's currently working on the post-processing of climate projections for DWD national users. And Bina has already advertised the work of DWD on the field of climate predictions. So we will be listening to Birgit overview what they are doing. Our second distinguished panelist is Esteban Rodriguez Guisado, who is the head of climate evaluation and modeling at the Spanish Meteorological Agency, AEMET, specializing in climate services and seasonal forecast. And our third panelist is Marie Ekström from Gallagher Reinsurance, who is the assistant director in the climate and sustainability team at the Global Reinsurance unit. So we are looking forward to listening the insight from our distinguished panelists and experienced users of climate information in general, on what they are doing, how they are expanding their portfolio of knowledge products and services, and how climate prediction might be used in this portfolio. So I first hand over to Birgit. Thank you very much for being with us.
Thank you for the introduction. You've already heard about our website, and actually I was planning to give you a quick tour of some features of the website, because it's like the core of climate predictions at DWD, or at least the core of our communication. We have climate predictions on 3 timescales, on the subseasonal, the seasonal, and decadal timescale. And Bina already mentioned that we show these predictions on different levels of complexity for different users. And also we try to be very consistent across all timescales so that it's like one-stopping shopping for all timescales. First, let's go to the basic climate predictions, which are for our basic users who do not have much previous knowledge. And it's highly aggregated information. Here, for example, you see the climate sub-seasonal prediction for Germany. And we always, it was mentioned already, we always show prediction in combination with its prediction skill. So here you see, for example, you can go to the prediction for southern Germany. And here it's a probabilistic prediction. So what you see on this diagram is for the first week of our prediction, because for sub-seasonal predictions, we always show weekly means, how the different ensemble members are distributed across all timescales. So you see the predictions, which was initialized yesterday, shows a slightly cooler week next week, cooler than the normal. What is normal is also driven from observations and is shown on the website. And the week after that, we have slightly warmer conditions than normal. And you can also choose temperature and precipitation here on this website. You can switch to seasonal climate predictions. And you could also choose an ensemble mean prediction. And also, Bina already mentioned it, we see warmer conditions than normal for the next month. For seasonal predictions, we always show 3-month means. I just want to switch back to our start site. We have the expert climate predictions for our more experienced users. You can also choose the different timescales. Let's go to the seasonal prediction. You'll always see the actual prediction for Germany is our intro site, but here you can also choose, for example, a prediction for Europe or a global prediction. And here we do not use the traffic light because you can't show a traffic light for each grid point, but here you see the prediction skill via the dot size. It's in the legend here. So when you have a large dot, in the past we had a good prediction skill. And if you have a barely seeable dot, it means we have no prediction skill at all. We also show the prediction skills in the expert section. So you can here look at maps for prediction skill for the different leads. We have different measures of prediction skill. I guess the correlation would be that which is the easiest to understand for users. We also have on our climate prediction website a lot of background information. Unfortunately, only in German, we have also a video on prediction skill because our experience is that users generally have a bit of problem when they first see climate predictions, how to interpret this prediction skill. We also have a category for specific climate predictions. This is for really advanced users. Because here we have for the winter months, we can improve our seasonal predictions by using some statistical methods. If you're interested in that, I'm happy to answer questions. And coming soon, to go really seamless, we have this our seamless time series. Here we show climate predictions in combination with observation and climate projections. So that would be the ultimate seamless goal. But you also see that it's not that easy because the data types are really different. We have on different time scales, like with observations, we show yearly means. Then you have the sub-seasonal predictions where you have weekly means with a much higher variability. So a lot of work went into this, and this is only for Germany, our seamless time series. Furthermore, I'd like to mention that we have a lot of user interaction. Very important for us is our annual user workshop with It's a user workshop on climate predictions and climate projections, where we get a lot of input from users. We can learn a lot about user needs, but we also have newsletters for our predictions, and we have a lot of one-on-one user interaction. So I guess my time is up for the intro. I'd be happy to answer any questions about our data or our user interactions or our future plans later on. Thank you.
Thank you so much, Birgit. I would be hugely interested in the way how you accommodate the user requirement, but perhaps after we have completed the whole panel, first opportunities to share some thought. So if you could, prepare to answer the question to what depth you are going and how you take on board the requirements. Our second panelist is Esteban. Esteban already introduced from the Spanish Met Office, and the agency is also providing the climate forecast. So Esteban, could you perhaps share your views on how to use and how to produce the climate prediction? Over to you.
Thank you very much, and thank you for the invitation to participate in the forum and to be part of the interesting discussion and to attend the fantastic summary of the work within the project and the other examples. We at the group at AMET are responsible of providing the downscale climate scenarios, and we do provide information about that through our advisor. We do have activity on climate modeling, and we are the responsibles of providing operational seasonal forecasts. We participate in a group together with the Spanish Office of Climate Change, with other institutions to make the information from climate projections available through a dynamic advisor that tries to present them in an easy and understandable way. We are participating in projects in the same in Central America. And this is one thing that I particularly mention because I believe it's relevant. But first, we are, as I said, responsible for providing the operational seasonal forecast for Spain. We integrate all the information from models, interpreting the information together with our predictability knowledge and mechanisms and the skill of the models. We coordinate Mediterranean Climate Outlook forums, bringing together other operational centers and bridging the gap between research and users community. But one of the things that happens traditionally when producing an operational climate predictions, in our case on the seasonal time scale, is that all the analysis procedure is done in a subjective way. And that has problems for the usability of the predictions. On top of that, the process is not easily traceable and not suitable for objective verification. But more than that, it's not useful for coupling with downstream applications, because one of the key aspects of the usability of climate predictions is linked to our ability of producing information really useful for decision making in the different sectors, and not only based on averages of the climatic parameters, but on those variables interesting for the users. We do have some experience on producing specific products. We have a long-standing collaboration with water authorities in Spain, and together with them, we have co-produced a climate service focused on providing the information that water authorities need for managing the reservoirs in what they call the reservoir rainy season, which comes from November to March. So around the need that the user planned, we have built a more or less complicated chain of production with several steps. I won't go into detail. The idea is that we add several elements, blending information of empirical and dynamical sources, post-processing, and gaining skill in each one of the steps. When we evaluate the product in each particular basin, we do find and we have information on the amount of skill that we manage to add from the starting point. And together with water authorities, we have co-developed a web visor trying to answer all the needs that the dam managers need on their day-to-day action. If you can see this visor is accessible through a Met web. We can see for the whole 5-month period, which is the more likely category for precipitation. But if you click in one particular point, you have the forecast plot with the different categories, the skill for each one of them, and the historical performance of the forecast against what has been already observed. You have that for each point for precipitation information, or the same for water inflow in each one of the dams that are represented by these yellow dots. So this is, let's say, our more mature product, but what we would like is to extend this to other prototypes that we have been working in. We did have some experience coupling a growing model and generating a seasonal forecast of crop yield for wheat and barley, rain-fed wheat and barley over an area of Spain. And our aim is to try to work towards operationally implement something like this. Because what we saw in this exercise, in this prototype, is that when comparing with actual production, we saw, and that is depicted for the red areas, the reddest, the better, the prototype showed the skill in predicting the crop yield for that particular yield. So our aim is try to set up an operational chain that tries to incorporate the expert knowledge into an objective way of generating the forecast, trying to blend information from different sources and improve the skill, and to generalize this sort of this kind of climate services that are currently generated for water and just in a form of a prototype for agriculture. But the other part, and this is where is relevant, what I was saying before about climate projections resources, is that if we intend to feed the adaptation community, although the climate predictions and climate projections are different, but we think that it worth to make an effort on the homogenization on how the type of product that we present to the community. So many times the community is used when working with climate projections to use daily extremes indices for temperature and precipitation, number of members of an ensemble or likelihood of surpassing certain thresholds, heat waves or cold waves. And the idea would be try to set up an operational chain, starting with seasonal products, providing information on this aspect, and hopefully incorporating subseasonal and decadal in a longer term. Part of this work may be done in a collaboration that we have with the National Research Council for generating an integrated web visor providing climate information for different scales and for different sectors. I'm just showing this is still a very early phase prototype, but the idea would be to present a web visor in a similar way that it has been developed for storage in the climate projections. So in principle, that's what we are doing and our plans, and I really can see very good synergy and eagerly expecting for the results of Aspect project. So thanks everybody for your attention.
Thank you so much, Esteban. Thank you really for the nice overview of all your application and the work, and also thank you for the very important initiatives that you are running. The Metal Climate Outlook Forum, for example, this is absolutely necessary, and that's what we need. Thank you very much. We will get back to you in a few minutes with more questions. But before then, I would like to welcome Mari. And Mari is from a reinsurance company, also connected with the industry that can really use the climate knowledge and climate services in order to influence the customer behavior or to influence their own services. So Mari, we are looking forward to your experience of using climate products for your business. Over to you. Thank you.
Yeah, thank you. And thanks for inviting me. It's a very interesting forum, and we're certainly keeping an eye on what's happening in the sort of data product space. So we're not producing data. We're not a data analytics company, but we are a heavy user of information, like many sort of insurance, reinsurance, and brokers, like we're a broking company, heavily reliant on these public resources. The private sector could not kind of pick up this in a realistic way, so we are completely dependent on these type of resources. But I thought I should say something about myself and the company, because I think most people are probably quite unfamiliar with what we do and how we use the data. So my own background is that I spent about 20 years in academia and government research before moving across to Gallagher Re, which is a reinsurance broker. So I got quite a lot of background in the production and verification of projection type work, and I wasn't super familiar with the finance sector at all before moving. And it's quite a closed sector, I'd say. It's quite difficult to get a good insight because it's quite commercially sensitive to what they're doing, and it's very competitive between companies. So Gallagher Re is a global entity. It's probably the distant third, probably, to be honest, a largest sort of reinsurance broker globally. We're present in about 50 different countries. We've got between 2,500 and 3,000 employees. We have clients in well over 100 countries. So the type of work we do is truly global in nature. So we kind of have to be across lots of different perils. I'm not working with brokering myself, so I'm part of the analytical staff. So many of the larger outfits will have their own research and development type teams. A lot of work that the broker's doing is that we license vendor analytics companies that do the pricing of risk. So you buy reinsurance on an annual basis. So that's sort of that's the time horizon, or the operational time horizon. So we use CAT models for this. So I'm not a CAT modeler, but that's kind of the workhorse of the industry. It's compared to climate models, they're simple models, but they basically connect the hazard with the exposure and the financial component that allows sort of to generate sort of a price estimation for risk. And my role is to sit between the analytics people, the brokers, and the clients to advise on sensible use of these type of tools in a climate change context. Admittedly, climate change context isn't big because the main work is operational, is for pricing. So that's looking back at the historical catalogue of events. So custom catalogues is not kind of forward-looking, but there are more sort of regulatory expectations for disclosures on sort of potential future costs. That is coming in sort of different formats across the globe. So different regions have different type of regulations and different specifications, more or less flexibility, which is really difficult for clients because the typical tools are not well suited for this type of information. So there is a huge learning curve going on in the sector. And also sort of at the moment we're focusing on the physical risk here, but there are also sort of other types of climate risks. So moving to net zero and climate litigation those sort of the type of topics that the kind of quite small team I'm part of is looking at. So I think I'll leave it there so we have some time for the panel discussion.
Thank you very much, Marie, and we really appreciate you being with us. It's interesting insight. So we are in different fora. We are working together with financial organizations, like insurers, like regulatory supervision agencies, including in Europe on national level. And so we are having this type of discussion, what the insurance sector and financial organization can do to contribute to reducing the disaster risk or climate-related risk. And many times we have the discussion about the predictions, so whether some parametric insurance can be based on climate predictions. Could you share perhaps from your experience, do you see this type of products taking off, being interested for the insurers or reinsurers?
Parametric insurance is hugely of interest at the moment. It's type of insurance that is deployed easily for specific payouts. So it doesn't involve sort of going out and making a damage estimation and sort of quite a lengthy procedure, but it's basically you pay for an insurance, and if a third party sort of independent verification commit that the threshold has been met, the payment is done. So it's really good for sort of smaller agricultural businesses and things like this, when you basically want to deploy sort of payment fast and not go through sort of lengthy claims process. So it is a very popular and targeted type of insurance, and we have a team with former World Bank members who are leading up. They're working a lot in the developing countries and public sort of insurance pools to address specifically this.
Thank you very much. I would perhaps give the floor to Freya, because I know that she is particularly interested in this topic, working with reinsurers. Freya, are you still with us? And would you like to come in for a second, perhaps mentioning the work that you are doing with reinsurance companies?
Hi, thanks, Yaro. So, yeah, we mentioned earlier one of our case studies is with the finance sector, with particularly the pension sector. But yeah, we're also working with the reinsurance sector through an initiative led by the Centre for Greening and Financial Investment, which is an institution based in the UK. And so, working with reinsurance people from reinsurance, we're going to have a hackathon in June. And so I was going to just quickly pull up the website and share it in a minute. But basically, just really quickly wanted to say, as an invite to everybody, that if you're interested in coming to a hackathon to look at reinsurance questions and how we can use prediction information, then please do come along. I'm just going to very briefly share the screen so you can see some quick details about it. And we will this up again at the beginning, maybe tomorrow as well, or briefly, to just show you and make sure you have the details and the link there. So if you just type in cgfi.ac.uk and search for Hackathon 2025, we're going to be looking at tropical cyclones and risk from tropical cyclones, particularly we're particularly interested in the occurrence of them hitting both America and Japan in the same year. So sorry, just to hop on, you're talking about the reinsurance sector. Thanks very much, Marie.
Thank you very much, Freya. And we will share this information tomorrow at the beginning of our next webinar. Yeah, I would like to get back to Birgit, right? And the question was about to what extent you are working with the users in order to accommodate their demand, and to what extent the value chain of your activities are really answering to the request from your your users in Germany or beyond. So can you share some thoughts on that? Thank you very much.
Sure. First of all, as mentioned, we have our user workshop where we have a lot of polls there where we try to find out what they need, what are the problems they have in understanding climate predictions, because I think with our standard users, it's getting better, but there was a lot of problem in understanding prediction skill and also the probabilistic predictions. So what we did, we provided more information. We worked on the wording of our legends to accommodate users. Our future plans are based on our user demand. So there's a lot of demand for extremes, obviously, which can be problematic because by definition, extremes are rare and rare events are difficult to evaluate. So for example, for hot days, we can not produce hot day plots for the entire year, but only for the summer months. There's a lot of demand for drought, so we are working in this direction. This is mainly from our users from forestry. What we already did said we are working with our agrometeorological department here together. So we have since maybe a year now, or only half a year, not sure. We have predictions of soil moisture, and this was a direct result from user communication. And what we also have said, we have with our regular users or heavy users, we have a lot of one-on-one contact as well. So we are always open for questions and do a lot of consultancy.
Thank you very much, Birgit. We have also one question from the audience, and this is from Suraj Desai from Leeds University, who is also working within the project and has conducted a large scale, who was the lead scientist on the large scale user requirement assessment. And he's asking, your DWD web interface is impressive. Do you know who's using the basic climate predictions and for what purpose? So if you could win a short answer answering Suraj's question, and you can expand more in the Q&A.
Yeah, as the basic climate predictions are used mainly, as far as I know, by communities like cities. They are looking at in summer, will there be a lot of heat? Do we need to prepare for, we have in Germany these heat plans, which are now since 2 years or something obligatory. So this would be a typical user for our basic climate predictions, and also just the interested public. So these predictions are designed to be for everyone.
Fantastic. Thank you very much. This is really, nice experience you share with us. We are looking forward to exchange the experiences, as this project is also aiming at similar application. We can build up on your expertise in improving delivery modes and so on. Thank you very much. And to Esteban, you have a nice set of application. I just wanted to ask, what kind of challenges do you see in translating the climate forecast into operational environment? You mentioned the collaboration with the water river basin authorities. You mentioned promising examples on agriculture. So could you elaborate a little bit on what are the most important challenges for you to do similar applications?
Well, one of the main challenges is the nature itself of climate predictions. The nature in the sense of we have an uncertainty. We may have a skill for one particular season or area or indicator and not for others. So the probabilistic nature and trying to identify the value for the users within the predictions is usually one of the main challenges. Our experience is that it takes a certain amount of time and a continued interaction with a selected user or a super user that can gather different branches of for example, some institution that gather together and knows the problems of all the farmers of a particular region, but needs time to build trust. And one thing that I don't know if has been mentioned that may help is working towards providing economical value assessments for the predictions. Because the first example that comes to my mind is that in principle we were expecting a relatively dry season, and we have had record-breaking rains along March in Spain, and that's part of what you may experience. You have a probabilistic forecast, and it's a challenge to try to explain, okay, if we are assigning a probability, that doesn't mean that the category with a higher probability needs to happen every time. But on the long term, depending on the cost of taking preventive measures or adaptation measures in relation with the loss, you will be gaining money. But trying to assess that type of analysis, we believe that it may be helpful for getting more users attracted to in how the decision-making schemes can be adapted to a probabilistic sort of information.
Thank you very much, Esteban. And finally, Mari, a last question for you. What could you suggest us to do? How to improve? We believe that the climate predictions have a potential, right? That they can improve the decision making, and we also recognize that there are difficulties to get that across to certain type of user, financial organization, the insurers. But is there anything that you could suggest us to do, to explore, to investigate, to improve the uptake of climate predictions in the through you as the insurance broker, risk broker, but essentially by the insurers themselves. So what can we do differently in order to reach this audience? Thank you.
It's tricky. So there's two different informations. It's the immediate, and then there's the far future. So the far future client interest is more it's more advisory in nature. So it's not really something that certainly we don't charge for. It's advisory. And for there, I'd say what would be useful coming from the kind of producing like upstream end of is clear communication about predictive skill and sensible use of ensemble data to avoid the selection, the kind of more opportunistic approach of selecting a model, a sample, doing something for 5-year time horizon. There's sort of over preciseness you see being used by vendor companies sometimes. So something that I do see a lot of, because we get a lot of different analytics companies and vendor companies presenting to us their climate change solutions, as they're called, is like I get quite a good overview of what's presented. And my sense is that they're much more a much greater faith than I do. So I think very good guidance on how to sensibly use it, and communication about the type of decisions that are sensible to make. Because even we talk about seamless, but actually the type of decisions you might make with this type of information is very different, because they are very different modeling frameworks and the uncertainties are different. So I think that would be useful. And I think there's a lot of homework also for the insurers. So I think what will be interesting with us, there's a lot kind of with the seasonal and decadal stuff, is understanding how we can make, I see quite a lot of noises around this. There's mistiming about when reinsurance is being sold and when there's predictive skill. So there's those type of alignments which won't be easy because this is a global market. So this is much broader discussion, but I think it's a sector in transition. So dialogue, having channels for dialogue is probably the most important thing.
Fantastic. So this is nice transition. IOPA, the European Regulator of Insurance and Pension Funds, is organizing on June 19 these type of dialogues with the insurers, but also with the potential users and risk analysts on how to close the financial protection gap, but also how to bring the insurers closer to helping to reduce the risk, encourage risk-reducing behavior by the clients, which is interesting topic to follow. And I think if anyone of you is interested to attend that meeting, I can share more information about it. Thank you very much. But also tomorrow we will be talking about similar things. We will be talking about application examples and how to break it down to specific input for policy or decision processes. And we will be talking also about the value of climate information. So I hope not only you but also all audience will tune in again tomorrow at the same time. But before then, I would kindly ask Chiara to help me with the slides. We have a short lab survey, right? We would like to get your feedback about what you think about the topic we have covered and so on, and what we could do differently next time. Chiara, yep, it's coming up. So if you go to the www.menti.com and post the code 33424902, or if you scan the QR code, you get directly to the survey. So this is an invitation to everybody to connect to that survey and help us to answering a few questions. So we will wait 1 minute for everybody to join in. www.menti.com and the code is 33424902. You can connect from your mobile device. You might connect from the desk computer, depending how you are connected, or you might scan the QR code. Right. Once you are there, please click on the thumb up icon so we can see that there is some life behind. And we can probably, yes, thank you very much. So we might go to the next slide and the first question. And this is really, just a warm-up question. And we would like to ask you, what is your level of familiarity with the climate predictions? So you might say you are not familiar at all, you have some awareness, and you actively use the predictions as the highest level. So as the answers come in, it's a nice distribution. Just to repeat that this is community practice. You are not expected to have a deep knowledge of climate predictions. You are very welcome to stay with us and interact with us even without prior knowledge of climate predictions. Is a sort of investment into pipeline, building personal and institutional capabilities, really starting from the scratch, helping you to understand the potential of climate predictions in your area of work or interest. And then we take you along this pipeline to more technical choices later on. So this is nice. Thank you very much. We have many people who are familiar with climate predictions and occasionally use them. I think the survey is now stable. We can move to the next question. Thank you very much. And the next question is, depending on your understanding of climate predictions and their usability, what is the biggest challenge in using them for practical decision making? Is it lack of accessibility to the data? Is it difficulty of understanding or interpreting the information? Is it the uncertainty or reliability of the predictions? Or is it the lack of integration into policy and business decision making and this type of thing? Right. So the answers are getting there, right? I see the leading challenge is uncertainty and reliability of the predictions, but also the lack of integration into policy and business workflows. It's clearly the second cause, and also the difficulties to understand and interpret the result. Thank you. This is extremely helpful. Thank you very much. Okay, it's stable. Next question, please. And there are only one or more questions left. We would like to ask you about the timescale of climate prediction. So what is the time scale of climate prediction? Is it immediate future, seasonal forecast? Is it next few years, interannual forecast? Is it multi-decadal, so time horizon of 10 years or more, or all together of them and potentially in a seamless, solar, timely, connected way? Okay, so it seems that the current preferred choice is the altogether, which is a nice confirmation for this project, which is investing a lot of effort of bridging the different predictability timescales into something which is based on the same interpretation of the physical factors. So this is really nice. Pinky and seasonal is the next. Brilliant. Thank you very much. I don't know whether we have one more question, Chiara, if we go ahead. Yes, and this is the question about overall, how satisfied are you with this session, and what do you think, how useful was this community of interest session, the first session of our forum? And this is from 0, not useful at all, to 5, which is extremely useful. And thank you very much for your nice response. So it's very useful, partially extremely useful, which is really nice. 27 answers. Typically we have 30, but we might say, thank you. This is absolutely something that we appreciate and are grateful for. Next slide, please. And then we have, we're working on developing a number of interesting products, the application examples and the innovative model and data set. But we're also working on digital handbook. And this is this handbook should increase the awareness of and potential use of climate predictions, insight, information, and intelligence generated. And we would like to ask a couple of questions regarding these. So we have, as we are putting a lot of effort, we would like to you to help us to guide the development of the handbook. So there's will be overview of science, detailed about how the climate predictions are produced, real world application, and data and result. Right, this is the overall outline. And here are the questions. Chiara, if we move to the second. Right. What type of content or information you would seek from a digital handbook like this, right? And this is, I guess, it's an open-ended question, right? So it's you might put anything what you would like to find in a digital handbook that will be produced by this project. What climate predictions are, for example, or how to assess their quality, where to find the information about the skills and predictability, whatever you think is very useful. Please drop it in the survey, and that will really help us in developing the handbook. Now it's the information are coming in. So it's downscaling information on which climate projections to use and how reliable they are. I think it's predictions and projections, how to find and download the data, how to build localized future scenarios and create climate indices, how to understand the predictions, which is very important, sunshine, temperature trends, possible connection with precipitation, thinking, how to interpret the data, that's critically important, and how to visualize the uncertainty. Thank you very much. And we have one more question regarding the digital handbook. And this is what information would you like to be emphasized the most, right? And there's already one response. Thank you very much. So it's a recommendation for stakeholders and sectors on the time scales. So what kind of information should we emphasize in the handbook? And you might think about these and drop some suggestion. There will be more emphasis on the digital handbook. You might connect to the team developing the handbook. You might offer help to design it. I think this is exactly the community champions that we are looking for. So if you would like to be among those that are co-shaping the digital handbook, please let us know and we can put you in contact with the team. Excellent. So we are running a little bit behind the schedule. So we are already 6 minutes too late, but I will give it 30 seconds for you to answer and then we will wrap up. Okay. Right. Chiara, we can move to the next slide, and you are welcome to compile these suggestions. And this is just the anticipation for tomorrow's session. So after this, very accessible format and discussion, we will be delving more into the technical aspect. What kind of case study can be showcased? What can we share with you from among the works that are being implemented right now and so on. So we will start at 2 o'clock like today, and Freya and Bina will be moderating the session tomorrow. So they have been, in the form of keynote speaker today. Tomorrow they will be moderators and bring in also the type of input from the first session to the more technical aspect. We will have a keynote by Tim Palmer from University of Oxford, and this is Tim is not working on the aspect project. So if you are really interested in technical advancement from beyond the aspect project and also from cutting edge science and simulation, Tim is going to cover those aspects as well. And then we will have a panel composed by Ralph from SMHI in Sweden, Daria from CMCC, my organization, and Simone, and they have prepared a nice overview about what is being done and what we are working on, and they will be able to answer your more technical, in-depth questions. So that's tomorrow. So thank you very much for participating in this first session. I wish you a nice evening and hopefully see you tomorrow.
Thank you
Thanks
very much. See you
to
tomorrow.
our keynotes and panelists as well. Thank you very much for having been with us and for the organizing team, Chiara, as well. Thank you and see you tomorrow.